Imagine you're an astronaut exploring the vast expanses of space and all of a sudden you're accidentally thrown out of your spacecraft's airlock. What would happen to your body if it were exposed to the vacuum of space if you weren't wearing a spacesuit? Actually, a lot of things. Let's take a look at the surprising and most shocking changes on your body if you were out in space unprotected. Before we start, make sure you like and subscribe to the channel. Turn on the bell for the latest notifications and updates. With that said, let's begin. When you think of space, you picture a dark, black, cold environment where if you stepped out of your spacecraft, you'd freeze. However, that's not true. You'll not completely freeze in space. In fact, spacecraft and other equipment melt in space. Sort of. Take the example of the James Webb Telescope. Although it is located at a distance of 300 million kilometers from the Sun, the radiation is so high that it needs to be constantly cooled down. The James Webb Telescope has a 5-layer sun visor and an active cryocooler ensuring the normal operation of extremely sensitive electronics. The Interstitial Space Station ISS and Hubble Space Telescope, however, aren't that lucky because they fly in the Earth's thermosphere at a distance of 700 kilometers from our planet. This layer is special because the substance can be heated up to 2000 degrees Celsius. It's worth noting that steel can melt at temperatures from 1350 to 1535 degrees Celsius. So, why hasn't the ISS or the Hubble telescope melted yet? That's because scientists came up with several hacks to protect the equipment and the space station's body. First, the space station and spacecraft are always painted white so that it reflects unnecessary heat and radiation. There is also excessive heat protection seals on the ISS. This is basically multi-layer insulation made from biaxially oriented polyethylene, terephthalate, and dacron. Such material can handle temperature fluctuations of 200 degrees, and inside the station itself, the indicators change by only half a degree. This also explains why spacesuits are always white in color. The spacesuit is therefore to save an astronaut, not from unbearable cold, but from the heat and radiation. You won't explode in space without a spacesuit. Hollywood's depiction of people in space is pretty exaggerated. They show people, unprotected by helmets or spacesuits, exploding or instantly freezing to death. In reality, the effects would be the same but less exaggerated. An astronaut floating without a suit in space wouldn't survive, but their demise would happen within minutes, not within seconds. And it would be a gnarly exit, with boiling bodily fluids and a nearly frozen nose and mouth. Space is a vacuum devoid of air, meaning that, unlike on Earth, there's no atmosphere and no pressure exerted by air molecules. Atmospheric pressure determines the temperatures at which liquids boil and turn gaseous. If the pressure exerted by the air outside a liquid is high, as it is at sea level on Earth, it's harder for bubbles of gas to form, rise to the surface, and escape. But because there is virtually no atmospheric pressure in space, the boiling point of liquids decreases significantly. Dr. Chris Lenhart, an element scientist for the Human Research Program at NASA, explains, "As you can imagine, given that 60% of the human body is made up of water, this is a serious problem. In the absence of pressure, liquid water in our bodies would boil, changing immediately from a liquid to a gas. In essence, all of your body tissues that contain water will start to expand." Some humans have actually been exposed to near vacuums and survived to tell the tale. In 1966, an aerospace engineer at NASA, Jim LeBlanc, was helping to test the performance of spacesuit prototypes in a massive vacuum chamber. At some point in the test, the hose feeding pressurized air into his suit was disconnected. As I stumbled backwards, I could feel the saliva on my tongue starting to bubble just before I went unconscious, and that's kind of the last thing I remember, he recalled in the 2008 Moon Machines documentary series episode, The Spacesuit. The formation of gas bubbles in bodily fluids, known as an embolism, also occurs in deep water scuba divers who surface too quickly because they go from an underwater environment of high pressure to low pressure at the water surface. For suitless astronauts, the blood flowing through the veins boils less quickly than water in the tissues because the circulatory system has its own internal pressure. But massive embolism in the body's tissues would result rapidly. A 2013 review in the journal Aerospace Medicine and Human Performance that looked at previous exposures to vacuums in animals and humans found that they lost consciousness within 10 seconds. Some of them then lost control of their bladders and bowel systems, and the swelling in their muscles constricted blood flow to their hearts and brains, as their expanded muscles acted as a vapor lock. No human can survive this. Death is likely in less than 2 minutes. According to NASA's bioastronautics databook, the vacuum of space would also pull air out of your lungs, causing you to suffocate within minutes. After an initial rush of air surged out, the vacuum would continue to pull gas and water vapor from your body through your airways. The continuous boiling of water would also produce a cooling effect. The evaporation of water molecules would absorb heat energy from your body and would cause the parts near your nose and mouth to nearly freeze. The remainder of your body would also cool, but it would do so more slowly because not as much evaporation would take place. An astrophysicist, Paul Sutter, told Forbes, "Temperature is a measure of how much energy atoms and molecules have to move about. And because space is almost empty, there's not much to move at all, making it cold. This also means that there isn't matter in space to transfer heat to. However, a person could freeze from the evaporation of their body's water and the slow loss of heat via the radiation emanating from their body. The lesson from all of this? Always wear a spacesuit. That's all for this video. Hope you enjoyed watching this one. Thanks for watching.